Now we are interested to find the equation of motion for pure rolling when a body is pulled from its center of mass. So the thing is like this. Suppose this is a cylinder and this is the surface, and you are pulling the body from here, so you are applying the force from this direction. So when you are applying the force from the middle of this body means through the axis, that means the frictional force must be working in this direction, in opposite direction that of the force. So this is the direction of the frictional force. Now the question is why? Because when you are applying this force, so the body has to roll in forward direction, that means in this direction. So the body has to roll in this direction. Now from this point, so the center, from the center the body is not getting any torque because you are applying the force from the center. It is passing through the axis. So there is no perpendicular distance of this force from the center. So that's why this force cannot give any torque. So the torque giving force, only the torque giving force here is the frictional force, which must be working in backward side, otherwise the body cannot roll. So at first here we have to consider two things. One is the linear motion. For linear motion, what thing is required? That is, suppose the body has a mass m. So this is the mass of the body. So according to the linear motion formula, so according for linear motion, so you have to maintain this thing, f minus small f. So capital F minus small f, and this will be equal to mass into acceleration. So this will be the mass into acceleration. Now the body should roll also. Now if the body wants to roll, then you require torque. So you require torque. So the torque will be given by this force. So this frictional force into radius, this will be giving the torque. So for rotational motion or for rolling motion, you require torque, that will be given by F into R. F into R, that is the force into perpendicular distance, and that will be the torque is equal to, we know that torque is equal to I into alpha. So I into alpha, now alpha can be written as I into A by R. Alpha is equal to A by R. So we are getting F is equal to, so from this we are getting F is equal to IA by R square. So now we will replace this F here. So suppose this is equation number 1 and this is equation number 2. So we will replace this value of small f here such that we will get, so F minus IA by R square, that is equal to ma. Now we are interested to find the acceleration, that's why we will take the acceleration in one side. So you will get F is equal to, if we take common A, so it will be m plus I by R square. So acceleration will be equal to force divided by m plus I by R square. Now from here we can take common m. So it will be F by m into 1 plus I by mr square. So we take it in the form of mr square because we know that I is also will be in the form of mr square. So that's why we take common m, and the relation becomes like this, 1 plus I by mr square. So this is the acceleration of a body when the force is given from the center or from the axis, through the axis. So when you give force through the axis, then remember the frictional force will be always in opposite direction.